Good afternoon, everyone. We have discussed how to write a multi-threaded program using the thread class extension and how to write the same using the runnable interface. Finally, we have discussed the way of writing a multi-threaded program using runnable interface. To implement a runnable interface, we need to define the user-defined class. Class name implements a runnable interface. Inside this implemented class, we need to redefine the run method in this form public void run. Then we need to create the thread class object. Thread class object is created. Say thread class object is equal to new thread of. The thread class constructor may take the parameter of runnable interface implemented class object. So passing the runnable interface implemented class object, we can pass the parameter to the thread class constructor. Then using the thread class object, we can call the corresponding run method by calling the start thread class object dot start automatically inputs the run method defined in the runnable interface implemented class. This is the way of writing a multi-threaded program using runnable interface. Having any queries in this? Having any queries in extending the thread class and implementing the runnable interface? Okay, see one more example. In this example, we need to define a multi-threaded activity. The problem is define multi-threaded activities. To print given integer and its and the sum of its digits. Write a main method to implement activities using the thread class extension. This is the problem. We need to define two multi-threaded activities. One to print the given integer, and in another multi-threaded activity, we need to print the sum of its digits. Suppose 120, 100, right? The sum of the digits is 1 plus 0 plus 0, right? 1 is expected. To achieve this, right, let us design the thread class extension, that is inheritance concept. We need to define two multi-threaded activities. One to print the given integer. Where is the integer coming? The integer is coming from the actual parameter from the main method. So design one class in such a way that the actual parameter is taken from the main method and the integer is processed here. We need to print the value just n, right? In this multi-threaded activity. Say class print t extends a thread. Class name extends the thread class. Inside this, we are defining some variable. Say int n thread t print int x. This is a constructor. The constructor takes one integer parameter, say x, which is used to initialize the instance variable x, instance variable n. N is initialized here. N is equal to x. inside the constructor itself, if we are right, we are going to call the default constructor n is equal to x, which is a constructor. P is equal to new thread of this. T is an instance variable which is created here, right? So the instance variable is allocating a memory thread T. T is equal to new thread of this. Then from the constructor itself, we are calling a method tree.start. Then the run method is defined. Public void run. Inside this, what we are doing, we need to print the given integer n. From the actual parameter, the formal parameter x receives the value and the value is assigned to the instance variable n. We need to print the value of n, right? Just the value of n should be printed inside the run method. Public void run, given the message system.out.println, integer is n. So only one executable statement is given inside this run method. And to design the another multi-threaded class to find the sum of its digits, let us have the class, say class digit sum extends the superclass thread, defining some instance variable, say int m comma temp. Temp is a temporary instance variable. This is used to try to print to find the sum of the digits of the given number. Let us check its purpose. Thread tt. Tt is an instance variable. Then digit sum, this is the class name. And this class name, we do want to initialize the variable m and temp. Temp is equal to m is equal to a. Since we are modifying the value of m, finally I want to give the message. The rewards of the given number is rewards of 125 weeks. 125 is stored in the variable m will be lost. So I am assigning it to some another temporary variable. That's the purpose. Temp is equal to m is equal to e. Then tt is equal to new thread of this. Here itself we are calling the run method tt.start. Then the constructor is closed here. Defining the run method, we do want to find out the rewards of the given integer, say m. So initializing s is equal to 0. The conditional check to be made is while m is greater than 0. Sum is equal to sum plus m mod 10. What happens? Suppose 125. 125 means from 125 we need to extract a value 5. To extract 5 in 125, we need to perform the modulus operation. So 125 modulus 10. What happens? The value, for example, here I will. Suppose n is equal to 125. First we need to extract a value 5. To extract a 5, perform 125 mod 10. 5 is returned. Now the value 5 should be updated into a variable, say sum is equal to sum plus n mod 10. Then from 125 the digit 5 is extracted. We need to extract the digits 1, 2 and 1 plus 2 should be processed. So to extract 2 from remaining, right, 12, right, before that 12 should be found by using n is equal to n by 10. This implies 125 by 10. Integer division is carried out, so 12 is assigned to the variable n. Then checking iteratively while n is greater than 0. While n is greater than 0. Here also while n is greater than 0. Then sum is equal to sum plus n mod 10. This implies, say, sum is equal to 5. initializing here sum is equal to 0. Again, while condition, while n greater than 0 condition true, then sum is equal to sum plus n mod 10, say 5 plus n mod 10, 12 mod 10. 12 mod 10 returns a value to 5 plus 2, 7 is processed. Then since n is 12, again performing the operation n is equal to n by 10. This implies 12 by 10. 1.2 actually write 1 is stored into a variable n is equal to 1. Then checking while n greater than 0, 1 greater than 0, condition is true. Then sum is equal to sum plus sum is current sum is 7 plus 1 mod 10. 1 mod 10 returns 1. So 1 plus 7, 8 is returned. 8 is stored in a variable yes. Then updating a value of n is equal to n by 10 integer division. This implies n is equal to 1 by 10. 1 by 10 integer division results in 0. Next taking while n greater than 0, condition is false. So control comes out of while and print the value of s. Print s is equal to say 8, which is equal to 1 plus 2 plus 5. Sum of the digits of the given integer. So in this logic, right, with the help of while and the conditional test, the conditional test to be made is right n is greater than 0. While n is greater than 0, n is the input integer. Taking if m is greater than 0, find right s is equal to s plus m mod 10 provided s is initialized to 0. Then update the value of m is equal to m division integer division. And the control comes out of while, right? That is when m becomes 0, condition becomes false. Then sum of the digits of temp, right? Because the value of m is modified inside the run method. So to keep that, we don't want to print that sum of the digits of 125 is 8. 125, this is not available in m gets updated. So temporary variable temp holds the value of 125 and the result is printed. This is the second class. Then devise a main method to create two child thread objects and then to call the appropriate run methods. Inside the main method, let's say class multitext main method is designed here into I for even right we can write dynamic initialization for variable declaration here and I is equal to 1, I less than or equal to 100, I plus plus. New print t of I. This is a way to call a constructor by using the left hand side. Class name, object name, then is equal to those things are completely missing here. A new print t of I means the constructor is going to be called here. Print t of I. Here this constructor. By calling this constructor, the thread object t is initialized, thread object is constructed, and the thread object can directly call the run method. New digits sum of I. This directly invokes this constructor, second class constructor digit sum, in which the instance variables m and temp are initialized, and from this constructor itself, the thread class object say t is directly calling the corresponding run method. That's all. No other executable statements in the main. Simply inside the main, what are we going to do? We are going to call the two constructors over the range of I is equal to 1 to 100. So it seems that two child threads are going to be created. New print t of I, new digit sum of I. This is one child thread, and this is another child thread. Two child threads are created, but the two child threads are called, for example, 100 times over the range of I is equal to 1 to 100. No more executable statements in the main thread. So if you want here, you can write system dot out dot println end of main method. Here you can provide system dot out dot println start of main method. File has been saved. Java C multex dot Java multex. Now see the result. Yeah, here first line start of main. Integer is 1. So what is integer here? Integer I is equal to 1. New print p of I. This constructor is called. From where we are called the run method. So integer is 1. 1 is printed. Then sum of the digits of 1 is 1. Next, this child thread invoked the corresponding run method. So here you can see the message. Sum of the digits of 1 is 1. Next, sum of the digits of 2 is 2. That means before printing the integer 2 in the child thread 1, child thread 2 tried and completed the corresponding activity. Then integer is 2, integer is 3. Sum of the digits of 3 is, sum of the digits of 4 is, integer is 4, 5, 6. Finally, right, you can see somewhere main is exiting. Could not find because of the length of the println messages are the same. So let me type like this. Start of main, end of main. Recompiling and running. Okay. This is the end of the main. Main finished here. Start of the main. So following the main program execution, the child threads completed their execution. Having any queries in this example? Do you have any queries?
So can we initialize the thread object inside the constructor directly, sir?
Initialize the thread object inside the constructor so that the variable t should not be reused somewhere outside the scope. Thread t and row x. Yes, possible because the variable t has not yet been used outside the scope. Thread t is equal to new thread of this. With respect to the local scope, the variable t or the object t is used here. No problem. Having any other queries? What is start? START method. What is start method? In which class it is defined?
It invokes the run method.
Invoke the run method. How is it possible means? when the thread class object is trying to call a start method, automatically the Java virtual machine calls the run method defined in that class. So here the run method is going to be called. So you can also call this way t dot run. Is this possible? Because what is actually run? Run is a method defined in the runnable interface. The class thread implements the runnable interface. So whenever a class extending the thread class means this thread class must redefine the run method, public void run. So t dot run, the thread class object t, t dot run, what happens? Is this possible?
No, sir.
What is the doubt in that? It's possible. Why means the class thread is designed in such a way that thread has been extended from thread has been implementing the runnable interface. So thread class implements the runnable interface. So what is the logic? The thread class object can have the rights to call any of its methods, right? So directly you can call the run method. Run method is actually a part of thread class. Thread class object calls the run method. Let us check this. File say this is possible because here let me explain. Runnable interface. This provides run method, void run, interface runnable. You need to think like this. Interface runnable provides this method, void run semicolon. Right? Okay. Only method declaration. Then a class, let's say class thread implements runnable. Thread class has been designed in this way. Class thread implements runnable. So what is the meaning? This void run should be redefined here. Public void run. Assuming some dummy definition is there. Now the thread class implements runnable one. So we can create a thread class object. Say thread t is equal to new thread. We can call its own method because what is run actually here? Run is said to be the method which overrides the version available here, right? The method is redefined here. Interface methods are completely redefined. That means the method is completely implemented here, right? Not overriding. So using a thread class objectivity, you can call a t dot run. There is no issue with this. But when the class print t implements a runnable, right? In that stage, uh, using this class object, we cannot call the run method. That means if you call right the thread user defined class object dot what happens start means that will not call the corresponding run method. So for that purpose, you need to create the thread class object thread t is equal to new thread of the runnable interface implemented object, then comma string parameter if necessary. Then using thread class object, you can call start directly t dot start either t dot start or a t dot run. That is possible. Having any queries in this?
Sir, is it compulsory to mention the access specifier as public, sir, for the run method? Won't it take the default as public, sir?
This one public void. Are you
Yes,
asking
sir.
this? Normally, in the case of interface, when you define the interface, all the interface methods must be redefined, right, using a public access is there. That is a rule. If not, a compile time error will be the result. Interface methods must be implemented in the class using public access specifier. That is a rule.
Sir,
Okay, I move on to the next. Yeah, yes, tell me.
sir, instead of creating a thread object in the constructor and then invoking it, can directly invoke in the main, no, sir.
Yeah, that is possible. I already explained with that. In complete reference, right? The author many times followed this style, simply creating a constructor, and from that constructor itself, the right parameter is received, and from the constructor itself, right? In this style, thread t, even right thread t is defined right here. Then t is equal to new thread of this. You can call t dot start or t dot run. So that way, right, the other had is no problem here. You can completely remove these lines of code. Third T, right, even the constructor can be completely removed. The portion of constructor can be right other than this one. N is equal to x. These lines of code, right, can be brought to main method. Third T is equal to new thread of the constructor or print T object is equal to right. You can create an object of this one. What is the first method? Thread class object, right? You can also call using thread class object, or you can use the object of this class. Print t a object is equal to new print t. Then using this object, you can call the corresponding the run method, public void run. So whichever is easier for you, right? You try to follow it. But in the normal style, right? Better to create the run method inside this class. Then here, right? You try to create the objects of the user-defined class. Then follow, right? Calling the corresponding start method. So that's what in the
Sir,
procedure I am mentioning.
sir, excuse me,
Yeah.
sir. Sir, what will happen if we call both t dot start and t dot run at a time? That means two times it will be executed, sir. Or any error will occur due to both at a time means t dot run and t dot
We need
start
to
at a
check
time.
logically.
If you uncomment that line, the t dot start.
Yeah, I understand. I think logically, right, what will happen before running the code? T dot start simply invokes a run method. One time run method is called. So following that T dot run, right, run method is called. So positively, right, no compile time error, but it is expected to have the result. Integer is entered twice. Let us check that. Yes, I think because of long output, some output is skipped.
Yes, sir.
Yeah,
Repeated, sir. I
integer is
repeated.
yeah, integer is 3. So try to follow the syntax with steps important. Extending the thread class, then writing the multi-threaded activity. Two ways, right? We have explored. Define the object of user-defined class, right? That is the extended class. Then call the start method using the object of the thread class. Thread t is equal to new thread. Or object of user-defined class. That's what I said here. Print t, right? You can create an object and directly call the run method. Otherwise, right, as you required, create the thread class object inside the main method and call the corresponding start method. But in the case of runnable interface, you need to create the object like this. Thread t is equal to new thread of runnable interface object, then message. Then you need to call the corresponding start method. Because yesterday also, right, one of you asked the question. What will happen, right, if the object is not passed as a parameter to this one? Directly, what will happen if runnable interface object dot start, what will happen? Runnable interface object, runnable interface implemented class object dot start will not call the corresponding start method. You need to pass the runnable interface object as the parameter of thread class constructor. Then only the thread class constructor can call the start method. Why it is impossible means the start method is actually defined in the thread class, right? You try to check the help here in the thread class. In the thread class, start method is available. Thread class object can have the rights to call the start method. That is a rule. So this simply calls, right? What will happen is the run method defined in the class, right? The Java virtual machine automatically calls from start to run. If not, right, as we have seen in this example, you can also directly call t.run. That is possible. But runnable interface object cannot call the start method directly. This is not possible because start is actually a method of the thread class. That's what here the runnable interface implemented object is passed as a parameter to thread class constructor. From where right the object can call the corresponding start method. Next one is this demo join method. The last class right we have seen. Some of the methods are deprecated, right, or removed in the later lesson. You try to go through the corresponding online test. ESLI method. The purpose of ESLI method is to check if the object is the thread child or the child object or simply the child thread is active or not. If the child thread is active means right, it has not yet finished its execution. If not right, the thread has completed its execution. So that stage, it is not in the alive state, right? Simply you can say it's in the dead state. That can be encoded right by calling the Boolean method isalive. So how to call the isalive method means you have to use the user defined object dot then you need to use isalive, right? Use it this way. User defined object dot thread class object dot isalive because isalive right again a method of this one thread class object dot isalive, right, in which child thread is currently alive. Or to check that, you need to use the user defined or simply child of the child thread object dot thread class object dot isalive. And another one is join method. The purpose of join is we are executing the sequential executions in the main method. In the main method, right, if we are calling a child thread to complete its execution, we have to call the corresponding join method to the complete to the child thread. So in that stage, the main method will be waiting until the complete execution of child thread is over. That's what right. This is a main thread is going to wait. So this is the concept, right? The main thread is waiting until the complete execution of a child thread is over, or when the child thread finishes its execution and control comes back. Till then, the main thread is waiting. See this example. I think the example is from a complete reference book. Class new thread implements runnable. New thread constructor is defined. From the constructor, the run method has been called. T dot start. Here, some sleeping time is set. Then inside the main method, class demo join. Say three child threads are created: OB1, OB2, OB3. Sequential execution. Here, first you are checking OB1 dot T dot is alive, right? So child thread OB1, OB2, OB3. So this stage we are expecting the child threads are alive. So since what is alive returns a Boolean value, a true or false. So we expect to write a true here because all of the child thread objects are alive. Then we are making a main thread to wait for the complete execution of child threads. Child threads complete execution is expected in this region. So system.out.println waiting for threads to finish. ob1.t.join. Which child object should have finished the execution? We are expecting ob1 should finish its execution. So ob1 dot thread class object dot join. Join is the method of thread class. So that object dot thread class object dot join, which means that when this line gets executed, main thread is expected to wait to finish the complete execution of ob1. Then likewise here ob2 dot join, then ob2 is going to be run, then ob3 is complete execution is expected. After that, the next sequential statement is going to be executed. Then finally, right, we are printing the contents of the status variables ob1, ob2, ob3. This stage, right, what will happen means sure before executing the statement or when executing the statement, previously ob1.t.join execution will be over. So ob1's execution is over. Clearly here checking if ob1 is alive returns a value false. Likewise for ob2 and ob3, the value false is expected. Let us check the result. Java demo join. You can see the waiting time written. Actually, in this waiting time, main will not continue its execution because we are forcing the main thread to wait to finish the complete execution of the child threads. Actually, this waiting time is inferred because here, sorry, in the code, right, there is no sleeping time given in the main thread. But in the child thread, right, 5,000, that is 5 seconds waiting time is inferred during the runtime. That stage, even here some other executable statements in the main method, but the control will not go to execute the main thread in the sequential order because here we have given the lock condition, right? Main thread should not continue its execution before the complete execution of the child thread. And check the order, right? The order is also important in this example. First, right, what happens in new thread 1, 2, priorities are set 1, 2, then 3. Thread 1 is alive, right? True. 2 is alive, true. Thread 3 is alive, true. Waiting for threads to finish. Order inside try 1, inside try 2, inside try 3. Inside try 1, inside try 2, inside try 3 in that order. So before inside try 1, OB1 should have completed its execution. How to check that? Inside try 1, before this message, say 1 exiting. Likewise, before this message inside try 2, OB2 should have completed its execution. So inside try 2, before that right 2 also exiting. Then before inside try 3, 3 also exiting. After that, no more executable, sorry, some more executable statements in the main, right? Only these 4 lines. Thread status are going to be printed. Child thread status. Thread 1 is alive pass, 2 pass, 3 pass, then main exit. Understand or not? Purpose of join. The purpose of join is since main is a calling thread, which is going to call some other child thread. The expected behavior is child thread should have completed its execution first. After the complete execution of the child thread, then only control goes to execute the statements of a main thread to execute. Having any queries? Shall I move on to the next example? Okay, the next example is synchronization. How multithreading is used to achieve the synchronization concept. Are you studying operating systems in this semester?
No, sir.
Are you studying operating systems paper? Okay. So in operating systems, you might be studying some classical problems. Say a producer consumer problem, dining class problem, right? So this kind of some processes oriented problems, multiple processes that can be executed. In this slide, only one thread or process is going to execute. For that, different concepts are there. Semaphores, the pure operating system concepts. I do like to tell just the basics only because this program is actually not a synchronized one. How Java achieves synchronization for the basic operating system support some concept like semaphore, monitor. In that, right, what will happen means semaphore or monitor will maintain a variable. Suppose when one process enters into the critical region, a critical region means the region in which certain statements are going to be executed by the process. That stage, after that, what will happen means once it enters into the critical region, the process sets some value in terms of writing mutex, mutually exclusive lock. So once it enters into that region, it sets the lock value to false, which indicates that no other process is allowed to enter into the critical region. What about other process? Other process are going to follow in a queue in the first in first out order. Say T2, T3, etc. Only T1 is true, which indicates that the process right T1 is inside the critical region. That means the T1 is currently working. Once when the process completes its task, when it comes out of that mutex, right, a semaphore or monitor region, it has to reset its Boolean value from lock into lock, right, for example, false into true. So when the lock value is true, right, then which indicates that another process can enter into the critical region based on true false values. That is the key concept in operating system to achieve synchronization. In Java, right, there is a chance of having this kind of a race condition when multiple threads are competing each other to finish their execution. We have a condition called race condition. In this example, see how the race condition is actually implemented. For example, one class call me. Inside the class call me, the method call is there. The method call tries to print some message. The message is going to be printed in opening and closing bracket. Whatever the message, when an object is trying to call this call method, it tries to print the message in opening and closing bracket. Opening bracket, then thread dot sleep, right, sleeping time, then message. After that, it has to put right this way closing bracket because MSG is printed here. Opening bracket MSG. MSG is passed as a parameter to the call method. The thing is, the call method is going to wait for some milliseconds. That stage, right, what will happen means before it's a complete execution, some other child thread, right, can take its execution because of context switch, transfers the control to execute to some other child thread, while the current child thread is waiting for, say, 5 seconds. So that stage, right, what will happen means we will get some incorrect order. Of course, see, this is one class, right, and call me. Then caller implements runnable. Here, no multi-threaded activity, simply the normal class, user-defined class. I already said all multi-threaded activities should be defined inside the run method. If not, the activity should be called inside the run method. Here the activity call has been called inside this run method, public void run. So this class implements the runnable interface. Class A caller implements runnable. As some messages are given, string msg call me target thread me. Then the caller class constructor here creates the thread class object T, and from there we have called the T dot start method. T dot start simply transferring the control to run method. Here call me target, right? Because the classes are defined in the same file, all are available in a public access code. It seems a different one. The code has been taken from a complete reference book. Call me, call me's instance is created inside another class caller, possible because of public access code. Call me caller, sorry, call me target. Then target is defined here. Target is equal to TARG. TARG means here the actual parameter. Here, call me target. This object is passed as a parameter to the caller class constructor. Caller class constructor receives here the call me actual parameter, which is further assigned to this call me instance variable target. So from here, we have to call the corresponding run method t dot start. Then here target target becomes object, right? So object dot target object dot call that has been given inside the run method. Inside the main method, call me target and new call me, right? Then the caller objects ob1 ob2 ob3 corresponding to this multi-threaded class are defined. So three child threads are created in this example: ob1, ob2, ob3. OB1 is trying to print a message within brackets hello. OB2 is trying to print the message within brackets synchronized. Object 3 is trying to print the message within bracket bold. Here we are also given the message ob1.t.join, ob2.t.join, then ob3.t.join. We are waiting for the threads, right, to complete their execution. But see what will happen in this example. Let us run the code. Class sync Java sync. The first object is synchronized. The first object is one hello synchronized gold. Each one is trying to print their own message within the brackets, but unexpectedly in several runs we can find that, for example, in the first run, hello synchronized gold. Second object, right? We can't say, right, in this opening bracket corresponding to second object or first object. Even to infer that, right, what you have to do means here you need to print the corresponding string parameter. As I have said in the previous examples, you can print the corresponding object name so that you can conclude which child object is entered into this run method. For example, here assuming that one object, right, puts opening bracket, then another one, right, printed synchronized. Then before its complete execution, another one put hello, then another one put bold. Like this, right? We are getting the scrambled output because we are expected to have which one means hello synchronized bold. Opening bracket hello, then the thread is waiting for 5000 milliseconds. That stage, what will happen means we do not want to execute some other statements in the main method. Like previous example, we are waiting the child threads to finish their execution. So before processing main thread execution, So end of main thread is expected to have at the end because of OB1.T dot join, OB2.T dot join, OB3.T dot join. But anyhow, OB1, OB2, OB3 are child thread objects. OB1 starts its execution. It puts opening bracket and puts message. Before it puts the closing bracket, the thread is sleeping for 5000 milliseconds. So this stage context switch will not transfer the control to the main method because a join method is introduced. Two more child threads are there. So unexpectedly, right, another child thread taken the execution to put their own message, opening bracket message. Then when the second or third child thread is right entering into this run method here, that stage what will happen means before putting the closing bracket, opening bracket message, then it has to wait for another 5000 milliseconds. That stage another child thread right may enter into the corresponding run method. So that's what in the different runs you can see the different output. Opening bracket hello, opening bracket synchronized, opening bracket hold, then closing. But we are expecting within bracket hello, then within bracket synchronized, and within bracket hold. That is to be object synchronization. Clearly, right, we can find since three child threads are there, these three child threads are competing each other so that a race condition is followed inside the run method. So to avoid that, what we have to do is two possibility here, right? You need to call the join method, right? So that once the object once execution is over, then you can call object two. But the simplest solution is we can synchronize the objects in such a way that only one object is going to enter into the critical region. That means here the critical region is run method. Only one object is allowed to enter into the run method. For that purpose, Java supports keyword synchronized. The keyword synchronized has been defined right like this, the general form of synchronized statement. Synchronized object, then you need to define the statements to be synchronized. This object is a child thread object, so that when the object enters into the synchronized block, no other object, no other threads or no other child thread objects are allowed to enter into this synchronized block, right? So synchronized block ensures that only one object is entering into that region. Other objects are simply in the waiting state. So for that purpose here, the same code, right? This should be modified here. The run method, the previous example, run method, what we have done, target.call MSG. Here, that should be defined right inside the synchronized block. Synchronized target, then inside that, right, we need to call this method, target.call MSG. You simply think that this is the implementation of the mutex you will be studying in operating system, right? Mutually exclusive log, the semaphore monitor concept. So just think of the object, say OB1 is entering into this region, that stage, right? Whichever is entering first, they are trying to complete their execution first, because assuming that when OB1 is entering into this run method, the object OB1 is said to be synchronized. Other objects cannot enter into this run method. So ultimately, right, even it puts opening bracket and putting the message. But to put a closing bracket, it has to wait for 5000 milliseconds. That 5000 milliseconds can be inferred during the runtime. No other child thread is allowed to execute that stage. Let us check it. Java C sync1.java Java sync1. Hello, right? You can wait for, right? The child thread is waiting for 5000 milliseconds. Hold, right? Second child thread is waiting for 5000 milliseconds. Then third child thread entered into that region, opening bracket, a synchronized, then a closing bracket. Hello, right? A first child thread is entered. Hello. It tries to put the closing bracket, waiting for 5000 milliseconds. That stage, no other child thread is allowed to enter into the critical region. But what about the order? Order need not be the same. But only thing is the object is synchronized. Hello, right? When the first object enters, right, it tries to put closing bracket. Then gold, right? Opening and closing bracket, synchronized. Hello, gold, synchronized. Here, hello, synchronized gold. Whichever is the object entering into the critical region, no other synchronized region, no other object is allowed to enter into that. That is the logic of object synchronization. In some situations or in some applications, right, when the objects are complex one and once the complete execution of one object is over, then we are restricting to execute some other task. That situations, object synchronization is necessary. One possible way to implement object synchronization is using this approach. The synchronized block should be returned. Synchronized target, the object should be returned. Then you need to call the corresponding run method. Target.call ms. Run method, right? Inside the run method, right? We are synchronized. Having any queries in this?
There does the priority change, sir? Does the priority change when we call the synchronizer means from 5 to 10 like that? It will be changed or remain same?
Wait. Whichever is the priority you are setting, object synchronization takes more precedence. So once one object is synchronized, this indicates that no other object is allowed to enter into the critical region. That means even when you have the higher priority thread, that stage, the higher priority thread, right, will not enter into this critical region, synchronized block. Only after the complete execution of the synchronized block, another object is going to complete its execution. Having any other queries? I think there is another possibility. You try to check your complete reference book, the latest version. This is one possibility to define the synchronized block. Synchronized target, opening and closing curly brace. You need to define the synchronization activity. One possible syntax. Another possible syntax, I think you check the latest version, it may be right. I'm not sure. Synchronized public void run, I think. Or the method should be defined right using a synchronized here. What is the method to be called here? Call method, right? So call, you try to check right before this void, simply the synchronized keyword. Or let us check in the first example. Synchronized void content. Let us check the first example. Java C sync Java sync. Yes, this is another option. Hello opening and closing bracket, then opening hold closing bracket, synchronized opening and closing bracket. Yes, this is correct. Another possible option. So instead of writing right this way, remembering right synchronized, then object to synchronize, then a synchronization activity should be defined inside and opening and closing curly braces. Even if you want to have a single statement, the synchronization activity, that activity should be put in this opening and closing braces. Instead, right, you can simply define the method to be synchronized. This means that the void call is going to be synchronized. So only one object is allowed to enter into this call method at a time. This is the simplest solution. Having any other queries? So in multi-threading, right, you try to learn the two different ways of writing multi-threaded applications, extending the thread class and implementing the runnable interface. Then basically know, right, the thread priorities, right? I ask you, right, to set the thread priorities for some child threads, setting higher priority thread and check the rules of context switch how the higher priority thread preempts a lower priority thread. Then go through these kind of things, the thread class methods, right? Various methods of the thread class. In the earlier version, right, some of the methods are available. Those methods are deprecated. Anyhow, we have seen these align method, right, and the join method. These are also right available in the latest version of Java. And try to set set priority and set name methods. Likewise, you can check right get priority. Okay, yeah, available. Get priority and get name. What is the name of the child thread that you have set using set name, and what is the current priority? Get priority. Right? Try to work with these methods. Then this one, right? A synchronization, object synchronization using two possible ways. Defining the method as a synchronized method and defining some set of statements, right, as the part of or the complete execution of the synchronization activities using this general form. So try to go through these examples, and if you have any queries, you can ask. We will discuss in the next session. Okay, thank you very much.
Thank you, sir.
Thank you, sir.